Section Q2 is about the properties of quadrilaterals. We'll start with a trapezoid. The feature of the sides of a trapezoid is that one pair of opposite sides are parallel. That also happens to be the definition of trapezoid. There is a feature of trapezoids regarding the angles. Each upper base angle is supplementary to its adjacent lower base angle. So I'll write that down and draw a picture. So because the top base is parallel to the bottom base, then this angle on the left, this upper base angle, is supplementary to this lower base angle because we have the theorem from parallel lines that says if two lines are parallel, then same side interior angles are supplementary. That is also true on the right side. So this upper base angle on the right is supplementary to this lower base angle on the right. In a parallelogram, opposite sides are parallel. That is also the definition of parallelogram, so that's considered a property, but it's more importantly, it's a definition. Also, it turns out that opposite sides are congruent in a parallelogram. In a parallelogram, opposite angles are congruent, and consecutive angles are supplementary. In a parallelogram, the diagonals bisect each other. We'll see that in a moment in an example. For a rectangle, since the rectangle is also a parallelogram, then the properties of the sides of a parallelogram also apply to a rectangle. Opposite sides are parallel and opposite sides are congruent. The angles in a rectangle have the same properties as the angles in a parallelogram, so we can say opposite angles congruent and consecutive angles supplementary. You also know that all angles are right angles, which actually makes the property of opposite angles congruent actually stronger because we can say that all angles are congruent. The diagonals of a rectangle do bisect each other because it is a parallelogram, but they're even more special than that because the diagonals are also congruent in a rectangle. For a rectangle, we know that all angles are right angles was the definition of a rectangle, a parallelogram where all angles are right angles. In a rhombus, the sides have the same properties as a parallelogram, so we can say opposite sides parallel and opposite sides congruent. In fact, in a rhombus, all sides are congruent. So that's actually a stronger statement, all sides congruent. And that is our definition of a rhombus. Highlight that, all sides are congruent. In a rhombus, opposite angles are congruent and consecutive angles are supplementary because it's a parallelogram. Okay, the diagonals in a rhombus, they do bisect each other, but they do more than that. They are perpendicular bisectors of each other. So the diagonals perpendicularly bisect each other. Another feature is that the diagonals bisect the angles. So they bisect the angles to which they are drawn. Let's get a picture of that. Here's a rhombus. Here's a diagonal. It is bisecting this angle here, and it's bisecting this angle here. So the diagonals bisect the angles to which they are drawn. On to a square. A square is going to carry all the properties of a rectangle and rhombus because a square is a rectangle and a rhombus. Opposite sides are parallel. All sides are congruent. All angles are right angles. Consecutive angles supplementary. And all angles congruent. Just like in a rhombus, the diagonals are perpendicular bisectors of each other. The diagonals are congruent, like in a rectangle, it gets that property from a rectangle, and the diagonals bisect the angles, as I just showed you in a rhombus. So those are all of our properties of our quadrilaterals. Now we're going to turn to the closure page, review quadrilateral properties, closure page. We're going to apply the properties that we just learned to these three problems. Given the parallelogram PQRS, PW is x plus 2, WR is 2x minus 6, and SW is x plus 6. Now I'm noticing that we are getting pieces of the diagonals. Property for a parallelogram and its diagonals is that the diagonals bisect each other in a parallelogram. So that means if SW is x plus 6, then WQ is also x plus 6. The diagonals bisect each other. That means each half is the same. So look at diagonal PR. The first half of PR is x plus 2, and the second half is 2x minus 6. So I can set x plus 2 equal to 2x minus 6 to solve for x. Subtract x from both sides and add 6. Since x equals 8, that's 8 plus 6 is 14. So half of the diagonal SQ is 14, so the other half is 14, and together that's 28. The length of SQ is 28. Number 2, you have to draw the picture yourself. Here's a tip. When you draw a quadrilateral, it's going to be different than drawing a triangle. The order of the letters matters. When you start drawing K and L, you have to keep going around the rectangle in that direction. So that's like a clockwise direction. So I'm going K, L, M, N. You can't zigzag it. If you had gone in the other direction, if you had gone counterclockwise, so K, L, M, N, that's okay also. What is not okay is if you zigzag. So K, L, M, N, that's wrong. You don't want to do it that way. So just keep going around the outside of the shape when you label your shape. Okay, we get diagonal information again. So KM is 7x plus 1, and diagonal NL is 28 minus 2x. This is a rectangle. Just learn the diagonals of a rectangle are congruent. That means 7x plus 1 would equal 28 minus 2x. So let's solve for x. The answer is 3. Number 3, you have to draw a rhombus. So remember to go around the outside of the rhombus in order. So if I start here and I go G, E over here, I have to put the O here and the M there. GO is given to us and ME is given to us. What do you remember about the diagonals of a rhombus? Go back and look at your note page. The diagonals of a rhombus are perpendicular bisectors of each other. I want you to draw the perpendicular mark here, and then bisect GO, so give me one tick mark on either side, then bisect ME, so give me a different set of tick marks on either side. The diagonals are perpendicular bisectors of each other. If GO is 12, that means half of it is 6, so half and half, 6 and 6. ME is 16, so this is 8, and the other half of it is 8. Do you see a right triangle there? There's a right angle in the middle of that rhombus. There's a 6 on this leg and an 8 on that leg. What's the hypotenuse of that right triangle? That's right, it's 10. That means each of the sides here is 10 because all those right triangles have a 6 and an 8 on the legs, which makes the hypotenuse 10. And the perimeter then of the rhombus would be 40.